So there's our technical support phone number. It's area code 727-489-0003. And our email address is support@bobcad.com. So if our customers have any questions regarding the software program, if you're stuck, if you're looking to maybe book online training, or have any questions at all with the software program, you can call us at that number or email us. Again, phone number is 727-489-0003, and email address is support@bobcad.com. Notice our area code is 727. We are in Tampa, Florida. That's our main office here. We can remote in for any computer, and we also offer on-site training. So if you have a large facility, a lot of machinists to help train with the software program all at once, you can have our training department be flown over to you and help you get the machine all set up and going there. Mostly we work with the software program and how to program it for your machine, but if you have any questions, we've got our training guys are well equipped to help you out. If there's any hardware issues, we can direct you where to go to contact your manufacturer to help with any of those issues as well. So we'll get started today. Hi everyone. My name is Eric. I am the demo tech here at BobCAD-CAM. I normally do the demonstrations of the software program for any potential customers. If they need to see anything being programmed in our software program, whether it's the CAD design, if it's any other module in our software program, whether it's milling, 3, 4, or 5 axis milling, it could be lathe, mill turn, which we program for lathes with live tooling. We program for wire EDM machines, and we also support laser, plasma, and water jet machines. In our newest software program, we also support drag knife for vinyl cutting machines. So we have a whole lot of support for all types of machines here. I'll get us started here to show my software program here of SolidWorks. You can see this part file here. It could be a SolidWorks part file, and we can also program in SolidWorks assembly files as well now. So you can see this option right down here for fixture. You could load in an assembly, the soft jaws, the fixture, and things like that to be able to make sure the tool avoids any collisions with anything there on the machine and be able to view that in simulation. So here's our part file. And before we get into the CAM tree to load that in, this CAM manager here, we can go to the top, and under this gear icon, we have this drop down for add-ins. So that is where you're able to open BobCAM for SolidWorks inside of SolidWorks and next to the feature tree over here in the other tree managers. You can also open it on startup, so you don't have to open it every time you open SolidWorks. This add-in shows up once you install BobCAM for SolidWorks on your computer. You want to make sure SolidWorks is closed down before you run it there. And then you'll register the software program, and you'll then see the CAM manager here over to the right from your feature tree and all the other manager pages here, your property manager, configuration manager. You'll have your CAM manager for BobCAM for SolidWorks. And from the beginning, I normally start here, and let's see here. I normally do it the old school way. From the CAM manager, I right-click on CAM defaults and go to a new job. We also have this new tab up at the top for BobCAM, where you can start a new CAM job up at the top here, simulate. So you have some larger icons up here that can be a little easier to see. So I'll start a new CAM job just to show you the runaround with this here. We start with milling, and again, all of our different machining job types here, turning, mill turn, wire EDM. And then we select our machine, whether it's a 3-axis mill, 4-axis mill. We offer 5-axis machining as well. And then we click the green check mark. Our next page that loads up will be setting up the workpiece. We'll define the workpiece here on our next page. So this is where we define our stock. You can see it creates a bounding box around the part file. We can create the stock around the a piece of cylinder, a cylindrical piece of stock around the part file. And we could also extrude it from wireframe, just like as we're creating an extrude boss in SolidWorks, creating defining a solid as our stock that we're starting with. So we got some options there of what stock type you want to use. And then our last page, once we skip over to next, we can define the machine setup. So we're defining our G54 work offset here. If I'm touching off at the top left of the stock here or at the bottom left corner, wherever you're defining your work offset at the machine, this is where you'll define it here in the software program so that everything lines up. And then I click OK at the top here. Work offset has been changed. Hasn't really been changed because I set it at the same location. But what it will do, you can see here, this is sort of where we're getting started with the geometry changes and showing how BobCAM for SolidWorks is fully integrated in SolidWorks. So once I click OK, if that machine setup has been changed at a different location, it will change the toolpath and the G-code in relation to the new work offset we have here in BobCAM for SolidWorks. Okay, and so I'll just start, after I've defined my stock and defined my machine setup, I would go and right-click on Machine Setup 1, and then go into my different milling operations. So we have drilling and tapping, counterbore operations, and then our Mill 2 axis. This is included in our Mill Express package for our standalone version for BobCAM for Rhino and BobCAM for SolidWorks here. We offer profile roughing and a finish pass, pocket, facing, engraving, chamfer mill, corner rounding, all the basic operations here. And the 2-axis milling is considered 2.5-axis machining, where if we look at the profile roughing, you can see the tool is going to start down here, start moving down in Z, then move in X and Y. And then once it's done with that first profile, if it needs to go to the next depth of cut here, it'll go down in Z again, and then move again in X and Y. That's our 2.5-axis machining versus our 3-axis machining that we'll be looking at next. Go to Mill 3-axis, and you can see something like this planar toolpath where the tool will move in X, Y, and Z simultaneously while the part, so it's going to be in X, Y, and Z simultaneous, giving us our 3-axis milling. So all 3 axes moving at the same time to give us Mill 3-axis there. So I'll go into right-click on Machine Setup 1, go to Mill 3-axis. I would next select my geometry. So I normally select the part file, and that is the rule of thumb for programming in BobCAM to select the 3D model, and that way if there was a boss in between the 2 pockets here, or if there was any other geometry, maybe clamps we could select here as our geometry as well, make sure the tool avoids that geometry so there won't be any collisions. So we select the geometry here, and then we select a boundary that we can contain the toolpath inside of. Since there's just the open pocket on the outside, when we're just pocketing these areas, we don't necessarily have to contain the toolpath inside of any area because we're roughing out everything that we possibly can on this piece of stock here. So I'm going to skip that boundary option for now. We can take a look at how we're setting up the top of feature. We're starting right at the top of the stock there. Nothing has been machined yet. Our next page, we can go to, let's see, we'll do an advanced rough. I did an advanced rough in that feature 3 axis that we have. We're just looking at all these different pages to begin with here. And so we can look at the other 3-axis Pro toolpaths that we'll be looking at today. We have our advanced D-level finish following along curved surfaces. Flatlands will mill any flat areas with a flat end mill. Equidistant will start around a boundary and then offset to the center, giving us a better surface finish. Pencil to mill any fillets. We have a planar toolpath going back and forth across the surfaces as a finish operation. And project curves to project a 2D shape onto a 3D surface to do any 3D engraving operations. So again, we're just doing the advanced rough we see over here on the left-hand side under current operations. Those are the operations we'll be utilizing out of our available operations. If there was a finish operation I wanted to add, I could simply just select on, for example, the advanced D-level finish and add it to our current operations list. And then I can sort the operations by highlighting one and then moving it up or down in the operations list here to change the order of operations. And then if I don't want to use an operation in the current operations list, I can highlight this D-level finish and delete it out with this delete button. Then our next page, we have options for posting. So work offset number. Number 1 would be G54, for example. 2 would be G55, 56, and so on. We can take a look at our tool here. We can define the tool and set up our feeds and speeds, our cutting feed rate, plunge feed rate, spindle RPM. And I can also use the system feeds and speeds, which if I finish this out for now, the system feeds and speeds will be found right below the stock page here. So if we see stock, we can expand that option over to the left and double click on the material we're using. So right now it says carbon steel. And if I double click, it'll open the stock material library. You'll see that it's very similar to the material library in SolidWorks. So in SolidWorks, you can pick a material in their library to get the density, the weight of your 3D model based on the material you select. Very similar, where we have carbon steel, aluminum, different types of plastic that you can select. It doesn't have the weight or density. It has the machining side of things here in BobCAM. So based on what tool material you're using, carbide, insert, high-speed steel, you can set up your feeds and speeds for each material type in here. We have very conservative numbers. We don't want anyone to break their tools right off the bat. So we do recommend that you contact your tooling manufacturer to make sure all of these numbers are dialed in for your specific tooling. So if I select the material type that I want, I can click OK. Instead of carbon steel, now it's cast aluminum. And then I'll see on the tool page that everything has been updated, the spindle RPM and cutting feed rate for cast aluminum instead now. And then if I wanted to change the tool, I can go here to the up at the top, go to tool crib, and then change the tool here. You can see all the different categories for roughing. We could use an end mill rough, end mill finish category. We have a tapered tool category, T-cutters, other form tools, barrel mill tools we offer now. So we went into some of the barrel mill tools in the last webinar. So if you're interested in looking at that specific tooling, you can see that in the previous webinar we just did. We'll go to the end mill rough category, and here at the bottom page is our tool library. Set up a little bit different than our older versions of BobCAM for SolidWorks. We used to have multiple pages of our tool library, our tool crib. Would get sort of convoluted, I would say. So it's all on one page here now. The bottom here is our tool library, and I normally sort by diameter. So I just click on diameter at the top. It'll start with the smallest there. If I click on it again, it'll start with the largest. And so all of these tools are preloaded in the software program. We start with a 3-inch face mill, going all the way down to 1/32 inch end mill, and everything in between there. And I can double click on one to modify it. If I don't have that tool readily available, or I'm never going to use that tool in the tool library, I can delete it to make a smaller list here. or I can add more tools in the tool library here as well. Once there's one that I see that I'm going to use, I can say the 7/8 tool. I can click, drag and drop it into the tool crib and select that as my new tool. I'll use the 7/8 tool and click OK. And then you can see the spindle RPM, cutting feed rate, plunge feed rate has changed based on the new tool I've selected and based on the material that I'm using. Then our next page are different cut patterns. We have some high-speed machining options with more spiral, adaptive roughing, some other CAM software programs you may be familiar with, call it dynamic machining or dynamic roughing. It's the same tool path that you'd be used to in those software programs where the tool will come down at the center, spiral its way out, and you can see the tricoidal milling here where the tool will retract just a fraction of an amount and rapid to the next location there for one directional cutting. And if we were doing zigzag, you can see it spiraling around the whole time there, keeping constant tool engagement for our high-speed machining options there. Let us know in the comments section if you guys use any of these high-speed machining options. I know that it's best utilized for softer material like aluminum, where the tool can go down to the exact depth of cut and hog out material with a pretty small step over. But with the tricoidal milling, it'll take a lot less time machining than doing all of those depth cuts in different material types. Our next page, we set our depth of cut, step over, allowance for finish pass to clean up, and all of our other options in the 3-axis toolpath here. I'll get into the rest of these in the 3-axis toolpath that I've created already. So I'm going to delete that one that we were looking at and go to the one I've already created here. Just double click on that 3-axis feature here. And we left off at this leads page where I could either plunge, ramp, or spiral into the material as a helical interpolation into the stock. Or, as you can see in this one, like this example here, all of this area, not in these pockets, but the opening right here, if I want to start from the side of the stock and work my way in with the side of the tool, I can uncheck this box center cutting tool, and the tool will start at the outside of the stock and work its way in with the side of the tool so that it doesn't plunge down into the stock and break a tool. Then our next page, rest machining. So if we had a previous roughing operation, we can tell the software the previous tool, maybe it wasn't programmed in BobCAM for SolidWorks previously. If you had some area, if you had another CAM software program, or if it was machined some other way, you can tell the software the previous tool that was used. The software will calculate the areas the previous tool could already fit into and calculate just the tool path that this tool can fit into, and essentially it'll start right where we left off from the previous operation and avoid any air cutting there. So a lot of good stuff here in the 3-axis Pro toolpath of BobCAM for SolidWorks. Linking, you've got different options for linking for each step over. You have a gauge check page to again make sure the tool doesn't have any collisions with the stock, the workpiece, and anything else with the fixture. We'll go over these last 2 pages here and then take a look at the simulation. The advanced feed rates, we have adaptive feed rates down here at the bottom where I can set a minimum feed rate. And what this does is when it gets into larger material at a time, like into these corners, the software can calculate how slow the tool needs to move to keep a constant chip load, and that can reduce chattering at the machine. Then our MDI page stands for manual data input. If there was any sort of dwell time I wanted to add, a different work offset, or just any raw text, I can highlight that command here, select before or after the operation, and add that command in. I can add any raw text here. You can enter anything you want here, or I select comment, and it will add the parentheses in here for a test comment that I'll type in right here. So then I'll hit compute, And we're really focusing on this area here for the opening. That's why it, yeah, how do I explain that? So when we go to the feature and go to the options, or no, the leads page here for entering into the stock, if I turned off the center cutting tool, it's only going to do any tool path where there is an opening for. Since there's no opening for these guys here, we can focus on those later and just focus on this opening for now and take a look at the simulation for this. To do that, I right click on the milling job and go to simulation. I'll focus on the workpiece and the stock here to zoom in and run it here. That was really fast, so let's restart it. I'll turn off the tool path so we can see it a little better and then run through it. I was going really fast because how the simulation is working, it is running based off of the G code. So each line of code is just going to simulate each one. And so you can see here the NC mode at the top right shows us how many lines of code it will be, about 3,800 lines of code. If I drop down NC mode, we could go to length mode next. That'll be the distance traveled with the tool, about 1,900 inches. And then go to time mode. And that will be about 24 minutes and 24 seconds based on the feed rate set for this roughing operation. So we've got our depth of cut going down each pass and our step over amount. And what we'll get into next is what we're mainly focusing on in this webinar is the full integration of BobCAM for the SolidWorks CAD software. So if we close out of simulation and we made any changes in the geometry in SolidWorks for this part file, BobCAM will recognize those changes and then compute the tool path according to the changes we've made. So if I go to the feature tree all the way to the left-hand side, I have created this extrude cut from this circle. I think we can see it here if I take a look at it right here. So there's our sketch, our circle there. I'm just doing an extrude cut with this circle all the way through the part file. I just right click on extrude cut and unsuppress that feature there. And I'll zoom in a little bit and we'll go to, once I click on the CAM manager, it will show me this message here saying the model geometry has been modified. Some machining features may no longer be valid. Do you want to auto update the CAM tree? So once I auto update the CAM tree, it will automatically update the geometry selected for the feature 3 axis. It doesn't have the tool path going down into it yet. And when I compute, it still doesn't have it only because of that checkbox we saw before here. I'll turn on center cutting tool, so it has the ability to go into these holes and the ability to go into the pocket here as well. So we have center cutting tool, no boundary selected, and automatic maybe. Oh, there we go. Okay, so from here you can see all of the. You can see the spirals here. I don't want the spirals. So let's go back to the leads page and go back to plunging. So it'll plunge inside of the pockets here and down into here. But on the outside walls, it will start from the outside and work its way in with the side of the tool. So there's a pretty smart tool path in that regard. And if I flip it over, I can see that the tool path is going down into the hole here. If I go back to the feature tree in SolidWorks, again, we can suppress the feature. So I right click on the extrude cut, select suppress. It's back to being a 3D model with no hole going through it. We can see the tool path is still showing. So then once I click on the CAM manager, again, it will show that code, that that message saying the model geometry has been modified. Some machining features may no longer be valid. Do you want to auto update the CAM tree? So yes, I want to auto update the geometry in the CAM tree. It's updated to my 3D model that has that feature suppressed now. So again, once I right click on the feature, I can compute the toolpath. I'll look at it from the bottom here so that we can see the toolpath modified once I recompute it. So you can see how BobCAM for SolidWorks is fully integrated in the CAD software program. You change the geometry in the feature tree. It will automatically update the geometry in the CAM tree for you to be able to recompute the toolpath for your updated geometry. If you import a new file or import new geometry into the file, it will avoid that geometry once you update geometry and recompute the toolpath. One other nice feature that I like when you're going into selecting geometry to show you the full integration of BobCAM for SolidWorks, you can select your geometry here, and you can select it here from the CAD workspace, or you can select it from the top here, your feature tree, and say if you had a 3D model, you can select it here and it will pick up the geometry from your feature tree right here. It will also allow you to, say for example, if you're doing a 2-axis feature and you want to select wireframe, when you select geometry, you can select it from a sketch like this suppressed one here, or any other sketch that you create in SolidWorks as well. So that's mainly what we're getting into. What we wanted to focus on today was the full integration of BobCAM for SolidWorks, that you can select geometry and compute the toolpath. Then you can go back into the feature tree in SolidWorks, modify any geometry of your SolidWorks part file. Then once you go right back to the CAM tree in BobCAM, it will automatically update the geometry, and then you can compute the toolpath based on the new geometry modifications. So let me know if you guys have any questions with the full integration of BobCAM for SolidWorks. We can take a look at some other options, like maybe doing a finish operation on these tapered pockets to show you how to, I think they're tapered, but different ways to program here in BobCAM for SolidWorks and be able to have everything cut to size before we run it on the machine. So I have to look at it as a wireframe like that. Yeah, so if we look at this, we can see that these are tapered walls. If I select one here, yes, so they're definitely tapered walls. So we can take a look at doing a 3-axis finish operation, either a Z-level finish or equidistant. They would both work for this, for the tapered walls there. And take a look at that feature because everything else has been cut to size. Before I get into the finish operations, we'll take a look at one other thing I thought of for the geometry selection here in BobCAM for SolidWorks. This is a newer option in our standalone version and a newer option here in our plugin for SolidWorks. If I right-click on Machine Setup and go to Mill 2-Axis, for any pocketing operations when I'm selecting my geometry, we used to have to create a sketch in SolidWorks, create any opening like this edge here for our pocket as construction geometry. So we don't have to extract the edges, or in SolidWorks it's called convert entities, to create the wireframe for your pocket. You can just select the surface, and then you can, let's see, select whole bodies. No, there should be a pocket option here. Let me select pocket, and then in the geometry, yeah, so even so, you don't have to select the checkbox anymore. SolidWorks will automatically understand the openings to any open pocket, and then once I go into the pocket feature here, I'm defining the tool. The next page, I have to use an advanced pocket. That's the only other option we need, so that you can see the example here. With a standard pocket, if it's a closed shape, it will do just that, a standard pocket. With the advanced pocket, it has the ability to start from the outside and work its way in for any basic shape for a 2-axis pocket operation as well. So then you can see here, I can backplot each operation here in the CAD geometry by right-clicking on an operation under the feature, like this pocket operation here, and selecting backplot. And I'm able to step through and see that the tool will start from the outside and work its way in. So there's your 2-axis option. We went over the 3-axis option of entering the stock with the side of the tool for a side roughing routine, an open pocket routine, rather than plunging straight down into the material. So everything has been finished up with the 3-axis roughing for all of this area. And for these 2 pockets, we'll get into the finish operation next for the tapered walls on these pockets next. And yeah, if you guys have any questions, please let me know in the comments section. I'm going to check that now, see if you guys have any questions. All right, and we'll take a look at the Z-level finish toolpath to finish this up here. We can right-click on Machine Setup 1. We'll go to Mill 3-axis. Again, when we're selecting our geometry, I always select whole bodies and select the 3D model in its entirety. That way, if there was any modifications to the 3D model, it'll automatically update that. And if there was any boss that could cause a collision, we would have SolidWorks, BobCAM for SolidWorks, avoid any collisions there. So I select the boundary. I could either individually select the edges here, or I can right-click on one of the edges and select tangency. So everything tangent to that line I'm selecting is going to select as well. Chain select all of those edges there. Then I scroll down to the Advanced Z-level Finish. Go to my next page here. Set my work offset. Set my tool up. I'm going to use a finish tool here under the end mill finish category and look for one of these ball end mills here. Let's do a 1/4-inch ball end mill. I have to drag and drop it from the tool library into the tool crib. And then now it's selected, I can click OK. My next page, starting from the top, working my way down. Setting my depth of cut. I'm going to go 10 thousandths to start with. And then we have some other options than just going down 10 thousandths. If there's still material remaining, we have this adaptive depth of cut here. So we can set a minimum depth set. I'm at 10 thou. Let's get down to somewhere between 10 and 5 thousandths. The software will calculate if there's more material to be machined, it'll set a smaller depth of cut for me automatically there. Then my next page, plunge down in. We have some different options here. I like this cutting extents option that I'll take a look at here. You can see with the cutting extents, the center line of the tool will end at the edge of the boundary. Or if you can see there's some area that would be remaining here still, I could select 3D extents where the tool radius will end at the edge of the boundary and clean up any areas there. We also have part bottom where the part could overflow to the sides here and mill out any size there for a finish operation. Then our linking for each step over, our gauge check page, and advanced feed rates, and MDI page that we went over earlier. So I'll hit compute, and you can see the tool path will be showing all of this here along the tapered walls. A big reason why I did the Z-level finish is because it only machines tapered walls and any curved surfaces. So if there were straight walls or any flat areas like down at the bottom, it's not going to mill those out. It's just going to focus on what we need to focus on there. Take a look at our simulation. Again, we can right-click on milling job and go to simulation from the CAM tree. We could also go to the BobCAM tab up at the top here in SolidWorks and go to simulation. Again, those larger icons are easier to find. And we can hit run, take a look at our roughing operation, and then take a look at the finish operation that we just programmed for the tapered walls there. Speed up the run speed here of simulation. I want to focus more on the finish operation here. That might... Okay, so it's still roughing this out. That's why it's got the 1/2 inch flat end mill. And then we've got the 1/4 inch ball end mill following along here. You can see all the extra material that the finish pass is going to clean up there. And then from there, we can go to the bottom right corner of our simulation. And you can see this green tab labeled Analysis. I normally show this a whole lot in our simulation where we select the drop down and select deviation, where we can load different colors on the stock depending on how much material is remaining. So everything here in green is cut to size with a plus or minus tolerance, or the tolerance of plus or minus 0.008 of an inch. And then if I zoom into the corners here, this teal color is showing there's more than 8 thou remaining in the corners. If I go over here, we haven't finished this up yet. The darker blue here is about 50 thou remaining along this surface here. So we would want to use a finish operation for this. But focusing here in the pockets, we would want to use a smaller tool to get into the corners a little bit better here. Obviously, since it's a sharp corner, there's not going to be a tool unless we maybe use a flat end mill to clean this up a little bit better. But it's a great verification tool to make sure everything is cut to size based on the SolidWorks part file that you have and the stock remaining from the milling operations you've programmed in BobCAM for SolidWorks. So to clean this up a little bit better, maybe we can focus on the geometry, or maybe creating a boundary to focus on this area as well. I'll just select these surface edges for my boundary also. I'll just go right here. You'll want to make sure that the boundary is always a closed loop or a closed chain. If there is any open geometry, it will not understand that as a boundary that you want to contain the toolpath inside of, so it wouldn't give you any toolpath if you did that. So there's the geometry for this area as well, and maybe I'll do a profile. Let's just take a look at that, see if that would help here in the corners. If I went to mill to axis, select geometry. Again, I'm just going to select the tangency for all of these here, and the tangency for the bottom of this pocket as well. And I'm just going to do a profile finish pass, so I'll delete out the profile rough here in the mill to axis. I'm going to use a pretty small tool. It's not going to be a ball end mill. We're using a 1/4 inch ball end mill. Let's use an 1/8 inch. Eighth inch flat end mill. I have to remember to drag it into the tool crib and then click OK. And we'll hit compute. Got both of those. Let's see how that looks with it, the getting into the sides there in our simulation. So if I want to skip any of these operations, like I want to skip this 3-axis roughing, I can just hit next op at the top here. Then I'll go to next operation again, and then I'll just take a look at the profile pass for these two pockets. looks like it machined some area there, and I can make sure by going to deviation, hitting refresh, and we're looking at just the tiniest amount of teal there, because that's the largest amount of material that a flat end mill wouldn't be able to get into. And ball end mill, we used a 1/4 inch ball end mill, so if you wanted to get any more material more than this 1/8 thou, we could use maybe like an 1/8 or a 1/16 inch ball end mill and uh, focus right on the corners here as a couple more passes there. Then the ball end mill cleaned up this area as well. We want to do a profile maybe along with the pockets here, along with this pocket, we could do that as well. But yeah, a lot of great options here to compute the toolpath and have everything cut to size here. If everything looks good, we can close out of our simulation. If this has all been cut to size how we want it, we can, let's see, is it at the top? No, there's nothing at the top here for the BobCAM tab. We would right click on milling job, and just like we have our simulation here, towards the top, when I right click on milling job, we have post, and it will ask me for the post processor here. I want the BC3X mill, and current settings, I want to make sure it's posting to V11, BC3X mill. So let's hit post again. It'll generate the G code in this posting window. You can see down here at the bottom, you have your CAM tree, you have your posting window. You have a couple other options that we've added in V11 as well, our tool tree and our operation tree. So let's look at from the CAM tree. The next one over is operation tree. We can change the order of operations here. If we wanted the profile finish pass to be moved up in the line, you could see I can highlight it and then move it up or move it down. And also our tool tree is where if we have multiple operations, say if let's say we have a lot of operations that we're using this 1/8 inch flat end mill with, and it broke, and we need to change the tool for all of those operations. We can easily just double click on the tool, change the tool out, change the tool number here, so we don't have to go into each operation and change it there. We can do it here in the tool tree. That'll save us time now in our computing time and making sure that we've found every operation that has that tool. It's found right here under the tool tree. Then I'll finally go to the posting page here, the last one here. And you can see this program for the BC3X mill. That is our generic FNUC-based G-code post-processor, G-code for a FNUC controller. BC3X mill stands for BobCAD 3-axis mill. So it's just a generic machine and a generic post-processor that is a FNUC-based post-processor. And I can scroll down. After the roughing operation, we can see the profile pass, and then and then so if I hit Control F, I can look for different comments here. And so I'm looking for the next tool, and you can see right before the finish Z-level finish operation, you can see in the Z-level rough, after the operation is all finished, you have your test comment right here. That's from the MDI page we looked at before. So you can manually add any data input, any test comments, any GRM codes that you needed to add before or after an operation will be printed there. If everything looks good, we can right click here in this posting window, and we can go to Save As. We can save it as an NC file, save it onto a flash drive, and then send it over to the controller from there. So that's about it. What we've been looking over today were some of the 3-axis milling tool paths, the advanced rough, advanced finish tool paths, and finishing this up with a profile finish as well. We mainly focused on if we have any different geometry. So once I've I've programmed all of this, and say, the design team sends you a different print, a revision, you have to go into the feature tree here in SolidWorks, maybe create a hole like this through the part file, something to do with the design. If you modify any geometry in the SolidWorks part file, you can go right over to the CAM tree, and it will automatically ask you, do you want to update the geometry? You'll say yes, and then you'll recompute the toolpath for the new geometry updates. So that really helps out. Instead of having to create a new milling job, or even just maybe delete the operation here and then create a totally new operation based on the new geometry changes here, you don't have to do that now. You can go right into the CAM tree, and it will automatically update the geometry. Then you just compute the toolpath for the new geometry updates there. So BobCAM for SolidWorks is fully integrated in SolidWorks. It will automatically update the geometry based on the SolidWorks part file or the SolidWorks assembly file to save you a lot of time with programming, so that you can get the G-code file onto your machine and start cutting parts. That's all we've got for today with our webinar. If you have any questions, please let me know in the chat section before I get logged off here. And thank you everyone for viewing the webinar live today, and also viewing the video here at a later time. Please let us know in the comments section and in the survey what you guys would like to see in the next webinar. The next webinar here is not going to be next week, but the week after. And so not May 15th, but May 22nd. That's going to be our next webinar, and it's going to be based on what you guys decide in the survey. If you have any suggestions, we would really like to know, so that we can have these webinars tailored exactly to what you want to see. So let us know what you would like to see in the next webinar. We'll let you know here in the next few days what we are going to cover in the next one on May 22nd. And thank you for viewing the webinar, and have a great rest of your day there. See ya.